Okay, good day, young mathematicians and Faculty Science High School students. This is going to be our second lesson. Okay, this is going to be one of our many video lessons to help you guys on the concepts surrounding our subject geometry. And for our second lesson on angle pairs, let's try to solve this bit of a challenging problem. It's a bit challenging, but I think we can most likely solve this problem. Okay, so in the diagram below, what is the value of angle x plus angle y plus angle z plus angle w? At first, this image looks chaotic. It looks like there's no way to solve it. Okay, but if you try to look real close at this figure that we have, look at the number of letters that we have in the number four variables. We're trying to find four variables here. And the most painful part about this problem, they didn't give you any numerical value as a given. We're just told to find the value of x plus y plus z plus w. Okay, but with our knowledge of angle pairs, of supplementary and complementary angles, this problem is going to be very easy for you guys. Okay, so let's try to solve this problem. Okay, so the very definition or the very insight that we can get into this problem is, if you try to look at the center of this model, you're going to see a triangle. This triangle here at the center. This is triangle ACF. It's the biggest triangle that we have on this figure. This triangle is somehow interconnected with the four angles that we have here: angle x, angle y, angle z, and angle w. Okay, so how are they interconnected? Let's try to erase the check marks. Okay, so how are they interconnected to each other? Since it's the biggest triangle here, it most likely would have the closest connections between the four angles. Okay, so let's try to take advantage of those connections. So we have here angle x. If this is angle x, most likely the measurement of this angle next to angle x, angle BFH, or adjacent to angle BFH, would be, okay, just a minute, would be 180 minus x. So we already have the measurement of angle BFH is equal to 180 minus x. We also have here another angle HDC. The measurement of angle HDC, it has an angle adjacent to it. It's angle Z. So it's going to measure 180 minus Z. And if you try to look closely at the measurement of angle Y here, it has an angle next to it. Okay, so let's try to write that angle. That angle would be BHF, if I'm not mistaken. So the measurement of angle BHF is equal to 180 minus Y. Again, this is 180 minus Z. This 180 minus Y. And then we have here the measurement of angle BAC. The measurement of angle BAC here would most likely be 180 minus W. Again, what are these types of angle pairs? So we call these as supplementary angles, and these are the supplements of the angles that we found here on our problem. So this is gonna be 180 minus W. Okay, so we have these four angles here. These are the supplements. Okay, so if we try to look closely again at our big triangle here. Okay, so let's try to use a different color. So for this one, we know already the measurement of this angle. We already know the measurement of this angle, of this green angle over here. We just don't know the measurement of this other green angle. So how do we find the measurement of angle ACH for this problem? What's going to be the measurement of angle ACH for this one? Okay, so since the measurement of angle ACH is missing, and we have here the measurement of angle CHE. We haven't yet found that yet. But we can also write another angle pair here. So the measurement of angle CHE here, the measurement of angle CHE, it's also equal to 180 minus y. So they're the same. So this also equal to 180 minus y, because it also forms a linear pair for this problem. Okay, so since we have here the measurement of this angle is 180 minus y, and we have here the measurement of this angle is equal to 180 minus z, and the measurement of angle ACH, that's an exterior angle. Okay, so what can we say about exterior angles again, guys? What are exterior angles? Exterior angles, okay, so exterior angles are angles, okay, whose sum is equal to the sum of the two remote interior angles that it has. The sum of the two remote interior angles. Okay, and what are the two remote interior angles on this figure? So we have the measurement of angle, okay, the measurement of angle HDC plus the measurement of angle HDC plus the measurement of angle CH, oh, this should be CHD. The measurement of angle CHD. CHD. And what's the measurement of angle HDC on this problem? So HDC measures 180 minus Z plus the measurement of angle CHD. So that's the measurement of 180 minus Y. So therefore the measurement of angle, what's our exterior angle here? That's the measurement of angle ACF. The measurement of angle ACF, okay, the measurement of angle ACF is going to be equal to 360 minus Z plus Y. Okay, so that means the measurement of angle ACF, or the measurement of angle ACF, is equal to 360 minus quantity Z plus Y. And it's also going to be equal to what? It's also going to be equal to the measurement of angle ACH. So why are they equal? Because angle ACF and ACH share the common vertex C at their center. So therefore they must be the same. This is the measurement of both of those angles. So therefore the measurement of this angle over here, that's 360 minus quantity Z plus Y. And we already know the measurement of this angle, this 180 minus W. So we just need to find the measurement of angle angle AFC. AFC for this one. BFH, okay? And then we have AFC. So it turns out that the measurement of angle AFC is also equal to 180 minus x, if you try to look closely here. So this angle x, and it forms a linear pair with angle AFC. So therefore this angle over here must measure also 180 minus x. Now we've completed our figure. So we have 180 minus W for this angle, 180 minus x for this angle, and then we have for this angle over here 260 minus quantity Z plus Y. So therefore, since we know that ACF is a triangle, therefore we can say that the total interior angle measurement of triangle ACF is 180. And 180 is going to be equal to 180 minus W. This is the measurement of angle FAC. Okay. Plus the measurement of angle AFC. Okay, angle AFC, which measures 180 minus x plus 180 minus x. Okay, plus the measurement of angle ACF. Measurement of angle ACF okay, which measures 360 minus quantity x plus y. And if we try to group this, if we have to group these two binomials as separated by these parentheses, so this is going to give us 180 is equal to 180 plus 180, so that should give us 360, minus quantity w plus x plus 360 minus quantity x plus y. Okay, so we have our variables here. So what we can do next is we can try to add these two constants. So we have 360 and 360. So it's 360 plus 360, so that should give you 720. And then we have here negative w plus or minus w minus quantity w plus x plus y plus z. Or quantity w plus x. Okay, wait a minute. Wx. Oh, this should be z plus y. I'm sorry. So this should be z plus y. So wx z plus y there. So 720 minus quantity w plus x plus y plus z. Okay, so now we have all of our variables here. We can transfer 720 to the other side so that all of our variables are on one side and all of our constants are on the other side. So this is going to give us 180 minus 720 is equal to negative quantity w plus x plus y plus z. Okay, and what's 180 minus 720? You can use your calcu, but most likely this will give us 540. Here we go. So this is going to give us negative 540. Negative 540 is equal to negative quantity w plus x plus y plus z. And since we don't want a negative sign here, we can divide both sides by negative 1. Therefore, the measurement of angle x plus y plus z plus w, when you regroup w plus x plus y plus z, so when it's regrouped, it's gonna look like this, since addition is an associative, has an associative property. So that's gonna give us 540. So it turns out for this problem, you don't have to find the individual interior angle measurements. So the measurement of angle x, the measurement of angle y, z, and w. You don't have to necessarily find each of them and then add all of them individually. So it turns out that you can solve this holistically. So you can just solve it as a whole. But you're gonna need a lot of manipulation. So we had a lot of mistakes. On this given problem, but in the end we managed to sort it out. Okay, so in solving problems in geometry, again guys, it's not going to be perfect. Okay, so it takes a lot of practice. Okay, and it's okay to make mistakes. Okay, so the best way that you can learn problems, to solve problems in geometry, of course, to practice, but the best way to really learn is to make a lot of mistakes. Okay, so if you don't make mistakes, you're not really trying on what you're doing. Okay, so you have to make a lot of mistakes first. As we did, we made a lot of mistakes. We had a lot of erasures here. But in the end, you're going to arrive at the right answer if you try to double check, try to recheck your solution, revise your solution, find a better method. Maybe there were some errors on specific parts of your solution, of our solution, to be exact. So we found the errors in our solution, but in the end we managed to solve it. Okay, so again, that's one of the life lessons that you can learn in our subject. Okay, so we managed to solve it. Again, the measurement of angle x plus y plus z plus w is 740, and maybe you have your own solutions, more elegant or much shorter solutions. So I'd like to know them on the comment section below. If you have those solutions, you can share them during our class. Okay, so that's the end of our second problem, and thank you for listening.